This video introduces our work titled Data Augmentation via Mixed Class Interpolation using Cycle-Consistent Generative Adversarial Networks applied to cross-domain imagery. The motivation of our study comes from the issue of limited data availability of non-visible imagery. Non-visible imagery in this work is defined as out of visible spectrum images such as infrared images, SAR images, and X-ray images. Such images are generally captured by special sensors which are often quite large, heavy, and expensive. So it makes having a lot of such images more difficult. This entails a dataset of such domains cannot have enough amount of image to work machine learning-based approach properly. Pre-training with publicly available datasets can be thought as an alternative. However, it's difficult to apply straightforwardly in many cases. Non-visible images looks quite different from visible images, and even datasets in similar domains are significantly diverged by the sensors capturing parameters or environment. To address the issue, we consider data augmentation approach to increase the training samples. Our approach doesn't adopt a standard data augmentation such as rotation, flipping, and cropping, but tries to synthesize new images via image-to-image translation which transfers visible image to non-visible images. Our image-to-image translation is based on Cycle-GAN employing the conditional training with image labels such as object classes to enable class-specific image synthesis. The trained model can generate class-interpolated images by blending the input images and class labels in inference time. This means it realizes more semantic mix-up rather than just blending input images pixel-wisely. We evaluate our approach on SAR image object classification task using a public dataset. This dataset contains small satellite images labeled ship or iceberg. We separate the dataset into test and training dataset. Subsequently, the training dataset is divided into 3 subgroups based on the difficulty of classification by hand. We train our Cycle-GAN model using this SAR dataset as a target domain, and a visible image cropped from the public dataset as a source domain. The model accepts the source and target domain images along with the class labels as input. The generators in our model are conditioned by the labels using conditional branch normalization, and the discriminators employ precision discriminator to learn class conditional manifolds. In inference, the trained generator which transfers visible to SAR domain is used to synthesize SAR images. The pair of different class images and its labels are blended with randomly chosen rates before the image-to-image translation to realize the mix-up with keeping the image reality. We use the generated image to augment the dataset and train an accent model which classifies the input SAR images as ship or iceberg. This table shows the average performance of accuracy, precision, recall, and inference scores. Our method outperforms other data augmentation techniques such as adding rotated images, the standard mix-up, and mixed cycle-GAN. To conclude, we propose a novel data augmentation for non-visible imagery. The approach transfers visible to non-visible images via Cycle-GAN-based method. The model is conditioned by class labels for class-specific image synthesis. The trained model further generates class-interpolated images, improving mix-up, and our approach shows significant improvement on a SAR ship iceberg classification task. Please visit our poster to have a further explanation and discussion. Thank you for listening.